Hello everyone, so welcome back to the online class of class 9 physics, and today we'll be continuing with our chapter number 9, force and laws of motion. And today we'll learn about the first law of motion. So these laws of motion were basically given by Newton, but the first law of motion, the starting of the laws of motion, were first understood and explained by Galileo. So this video might be a little bit longer, so I suggest you to listen very carefully. Once Galileo was playing with some balls, means small spheres or balls, and he saw that if we take any plane path and we take a spherical object, we push it, the object rolls on the path up to a certain distance. Now if this object, this spherical object is left to come down or roll down through an inclined plane, that means one ramp or slope has been taken and the object is left here, and obviously what will happen when the spherical object is kept or placed at this point and it is allowed to roll down, due to gravity the object will come down, will roll down and will roll onto the plane, which will go to a certain distance. Now he was playing with it, he was playing with the ball and the inclined plane, and suddenly he thought of an idea. What he did, he was basically taking the ball and leaving it through the inclined plane from the top of the inclined plane, and the ball used to roll down and reached up to a certain distance. Every time, means he didn't push the ball, he simply hold the ball here and left it. The ball used to roll down and reach to a certain point on the ground. Now he was doing these experiments, he was playing with it for some time, and then he noticed that every time when he was leaving the ball from this height, the ball used to reach every time at this position only. Means sometimes little bit more or sometimes little bit less than this position, but almost it was nearby the same position only, little bit less or more, or little bit less, little bit far or little bit near. Now he thought, why is this happening, or why did this happen, that whenever I am leaving the ball, why did the ball always roll down to a certain distance only, not extra more than that, or not so less than it, so less distance than it. Then what he did, he took another inclined plane of the same size, means same size, same height, and he kept it here. He placed it here, and then he left the ball to roll down. He left the ball from here, the ball rolled down and rised up to this plane. This was the first plane and this was the second plane, or we can say slope. First slope and the second slope. So when the ball was left from the first slope without any extra force, means he was not pushing the ball, he was not kicking the ball, he was not putting any extra force on the ball, he simply hold the ball here and left it. The ball used to roll down by itself and then come to this plane, and in this plane, or sorry, in this slope, the ball used to rise up to a certain height. Again he left it, again the ball rolled down, again went to the certain height. So every time he rolled it down, the ball used to reach the same height from where it was left. Then he thought that it might not be every time possible. Let me check with some another slopes. So what he did, he took another slope with little bit less height. So in the first slope, for example, this was the first slope, for example, and the ball used to reach up to this height. Then he removed this slope and took another slope of less steep, means of less angle. This angle of the slope was less than the previous one. So it was less inclined, more long. So here what happened, he left the ball, again the ball rolled down and rised in this slope up to this height. Means the ball used to always rise to the certain height, means to the same height from where it was left. If the ball was left from this height, then the ball will rise to the in the second slope up to this height. Not more than that, not less than that. If some extra force is given, then it will fly off. That's different. Then he took another slope of little bit more lesser height, more lesser angle, and he tried with the third one. Here also he noticed when he used to roll the ball down, leave the ball used to roll down and go to the slope and reached up to that final height only, means to the same height from where it was left. So from there he got the idea, or he got a experiment in which he told that if an object is left from a certain height, it always goes to another certain height, such that both the heights are same. That means whatever force was in this ball from the first slope, the ball always used to go to that another slope to attain that certain height only. Means the height for both the endings, for both the events starting and ending, the height used to be same. So from this he concluded that at whatever height the second slope may be, means whatever the inclination of the second slope may be, the ball always reaches to the certain height or to the same height from where it was left. These ideas or these theories were further studied by Sir Isaac Newton, and then he came to an conclusion, or he gave a law which was termed as the first law of motion. And after that he gave two more laws, but before that he gave the first law of motion, which was stated as an object remains in a state of motion or rest until and unless an external force acts upon it. That means if I have an object, any object on a plane, and if I do not disturb the object will stay in this position. But if I put some force on the object, then the object will move. That means the object wants to be in rest. It does not want to move until and unless I am putting some extra force on it, which makes the displacement or change of position of the object. Secondly, this law can be also stated as if an object is at motion. For example, a car is going in some particular direction, the car is moving. The car always wants to be in that motion until and unless the brakes are applied and the car stops. That means if we want to stop the car, we have to put some extra effort or extra energy, and in this case that comes in the form of brakes or friction. So this, for the first law of motion, was stated as, the definition we can say, an object remains in a state of motion or rest until and unless some external force is applied to the object. So this was the valid statement given by Newton, which used to validate the experiment done by Galileo. As Galileo was playing with the spheres and the inclined plane, and when he was leaving the sphere from a certain height, the sphere used to roll down and rise to a certain height. So when the sphere or the ball is rolling down, it is getting some force and it does not want to stop. It always wants to go or be in the movement of the because of the force. Now when the ball comes in contact with another inclined plane in opposite direction, means it has to rise up, it always goes to the certain height from where it was left. That means the force which was attained by the ball means like if this was the plane, if the object was here, when rolling down the object will attain some energy or some force due to which it will rise on the another plane. So it always goes to the certain height up to where its energy is energy finishes or the applied force is reduced so that the object can stop or it can we can say it can come to rest. So this was the first law of motion. So simply it can be told as an object remains in a state of motion or rest until and unless an external force is provided or applied to the object. This is also known as law of inertia. So inertia, we can say the first law of motion is also or can also be said as law of inertia. Due to this, the first law of motion can be also termed as law of inertia, and inertia means the state or situation of an object where it is moving or it is not moving. If it is moving, then we will need some force to stop it, or if it is not moving, then we will have to apply some force to make it move. So inertia is normally the state of an object. State of an object, either rest or motion. Now inertia depends on the weight of the object. If the object is more heavy, we will need more force to stop it or to make it move. So inertia depends on mass of the object. So if an object is more heavy, we will need more force to make it stop or to change its motion, or if the object is at rest, we will need more force to make the object move from its initial position. So we will discuss more about this inertia topic in the next video. This much only for today. I suggest you to read page number 116 and 117. Thank you.